Go ahead. Okay, yeah, this is now fine. So, hello everyone. I was just checking if the connection is there or not. So, how's everyone? Shri is there. Srinivas. Okay. Sandhya, Karthik, Meghna. Meghna, how are you? Anushka, that is Isha. How are you, Isha? Let me know. So, this is the second session of, you can say, wave optics. Okay. First session we had 2 days earlier. Now this is the second session. Ayushi Sharma, Anjali Shavani. Okay, you guys are already there. Good. Hariharan. Fine. Anushka, fine. Anjali, hi. Bhavna. How are you guys? So you guys are having a good time as well as you guys are having your free boards and boards lined up, right? So let's start with the session. Let's see if you guys can learn things. Okay. So right there on your screen is question number 1. Let's see how many of you can solve this one. Ranjan Alok, Kant, Gautam, and Gulfan. Gulfan, right? So everyone give a try and let me know what is the answer. Then I'll you can say guide you how it should be done. Okay, Sanskriti and everyone, just settle down and try this one. Anjali says, okay, Anjali, like always, you're the first one who gives correct answers, or you can say who gives answers. I'm not revealing whether it is correct or not. So yeah, go ahead. What about others? Okay, Meghna is also. Is it C? Saurabh. Okay. So let's do it. I'm doing it. Let's see if you guys can get it right. So maximum intensity whenever there is a superimposition of two intensities is root I1 root I2 whole square. This is something which you should be knowing it. It's a simple one. And minimum is root I1 minus root I2 whole square. So putting the values of I1 as 4i and I2 as I, okay, you can see that I max, okay, no need to write that again. I just need to put the values. So, okay, 4i root of plus root of I, okay, no need. There is a bit of, okay. So what is this value, everyone? Let it be solved, guys. Yes, 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 yes. So yeah, that is correct, Saurabh. Because Saurabh, yeah, yeah. I'm doing it. So it will become 3 root I, that will become 9i. Okay. Similarly, for the other one, it will be root of 4i minus root of I. There is a bit of lag. Okay. Just give me a few seconds. Okay. So it will become 2 root I minus root I whole square, which is going to become I. So maximum and minimum I can see is 9i and I. So everyone got it or can't? Okay. So how many of you are fine with that? Or what is the thing that we learned from this question? That's a simple thing. Maximum intensity should be equal to root of one of the intensities plus root of another intensity to the power 2. And I minimum will be root of I1 minus root of I2. And many questions come from this formula only. Many questions, and you can say means and need, as well as some questions in advance, because this is the question which came in 1990, 1988 for 1 marks. That is fine. So I think, yes. Let's move to the next one. Let's see how many of you can do this one. Anjali, let's see if you can do this one, okay? And everyone else as well. Ratio is 9:1. Correct, Meghna. So in double slit experiment, okay, this is a bit simple question, but still it came in 1981, 2 marks. So in Young's double slit experiment, the separation between the slits is halved and distance between the slits and the screen is doubled, the fringe width. So this is directly a formula-based question. Let's see how many of you can do this one. This is question number 2 for the day. Go ahead. D is the correct answer, Anjali. Okay. Isha, Upkant, Meghna, you guys are saying D. Okay. So, okay, let me just do it. So, omega is equals to lambda capital D by D. Now, see the conditions given. The separation between the slits is halved, and distance between the slits is, you can say, doubled, right? So, D is doubled, and okay, no, D is halved. Okay, good. Okay, and capital D is doubled. Actually, there is a bit of lag. Okay. So putting the values, you can very clearly see that it is going to be 4 times. Omega will become 4 times. So the correct answer is D. How many of you are fine with that? It was simply a formula-based question, and it was not at all tough. But still, questions like these come in exams, okay? Because at the time of exam, remembering the formula is also a challenge. Yeah, you may be finding it simple, but at the time of exam, when you are having like 80 chapters in your brain, remembering even a single formula is a task, right? So okay, let's move to the next one. Let's see how many of you can do this one. Question number 3. Now this is a bit quality question. Let's see how many of you can do it. So in the ideal double slit experiment, when a glass plate of refractive index 1.5 of thickness T is introduced in the path of the interfering beams, wavelength lambda, the intensity of the position where the central maximum occurred previously remains unchanged. They may come because every question paper is a mixture of tough questions, moderate questions, and easy questions. So if they are going to pick a easy question from wave optics, they will come up with such questions. Okay. So every question has all the levels: tough, easy, simple, everything is there. So it all depends on the mood of the examiner. If he is setting the question from wave optics as simple, he may come up with questions like that. Okay, how many of you can do this one? This is a bit of quality question. Let's see how many of you can do it. B, you guys are saying B. Okay, Meghna says B. Okay. Okay, let me just see. The intensity at the position where the central maxima occurred previously remains unchanged. So the condition for that should be path difference due to the slab should be an integral multiple okay of lambda. Okay, A is the correct answer. Okay, Shavani says so that means path difference will be n lambda. Now what is the path difference because of the insertion of this extra glass plate? It will be mu. Okay, this color is not nice. Okay, let me just check. It will be mu minus 1 into t, where t is the thickness, should be equals to n lambda, where n is it should be integral multiple, so it can be any integer 1, 2, 3. Now thickness becomes n lambda by mu minus 1. Okay, now you guys are changing your answers. That is good, but try to get the logic over there. So for minimum t, n should be 1. So thickness comes out to be lambda by mu minus 1. That is lambda by 1.5 minus 1. That is lambda by zero point 0.5. That is 2 lambda. So the thickness of the slab should be twice the wavelength. How many of you got it? This one, everyone? Go ahead and let me know. Okay, so the answer to this one is E. Okay, are you guys fine with this question? So a quick revision of all things we have done here. How many of you are fine with the perfectly fine with the first one? Let me know, because it is something which comes mostly in NEET and mains. You guys are fine? Meghna, that is fine. Don't be sorry, just learn, okay? Okay, so maximum is root I1 plus root I2 whole square, and minimum is root I1 minus root I2 whole square. The next question was simply a formula-based question, okay? So yeah, they can come up with like doubling it, tripling it, or whatever numbers they can come up, and you guys are mature enough to answer that, right? The next one was a bit tricky, and here all you need to remember is the path difference because of the insertion is mu minus 1 times the thickness of the slab, okay? The path difference that is achieved because of the insertion of any slab in the path of, you can say, in the path of the light is this one, okay? So I think this is enough for today, guys, okay? uh, this is enough, and you can subscribe, and you must have got the link for in the description. This is you can say enough from my side. We'll meet in the next session, everyone. Ritika Sani, you can find the second part of ray optics, okay, in the channel. Okay, so this is enough from my side, guys. We'll meet in the next session. Okay, see you, Anushka, or you can say Isha. Okay, we'll meet in the next session. Good night.